we're looking to answer these test prep questions, and here's a video solution for you. The first problem, we want to find the Maclaurin series for arctan of negative 3x. Well, they already gave us one for arctan of x, so really we just need to go into what was given to us, and where there are x's, there's just one, we are inserting negative 3x. So this is the function that we have. Now, instead of x, it's minus 3x. So we get minus 3x to the 2n plus 1 all over 2n plus 1. Okay, well, if we want to simplify that a little bit, we can write that as the sum from 0 to infinity. And what I want to do is just expand that. Yeah, expand that. So we get negative 1n times negative 1 to the 2n plus 1 times 3 to the 2n plus 1 times x to the 2n plus 1 all over 2n plus 1. Okay, so that's all. That's it. I mean, we could have stopped here, but it's typically nice to have your variable in this x be standing alone. But either one of these is completely correct. Right, so then in the next problem, we are, well, what are we trying to do? Oh, and we also need to determine the interval of convergence. So, let's see. So to determine the interval of convergence, we're going to do a ratio test. So I'm going to look at a of n plus 1 over a of n limit as n approaches infinity, and see if this is less than 1, or see when it's less than 1. And so to do that, we can ignore those negative 1s. So we don't need to worry about the negative 1 to the n. So what we have is 3 to the 2n plus 1 plus 1 times x to the 2n plus 1 plus 1 all over 2n plus 1 plus 1 times 2n plus 1 over 3 to the 2n plus 1 times x to the 2n plus 1. So if we simplify the left side, we end up with 3 squared times 3 to the 2n plus 1 times x squared times x to the 2n plus 1 over 2n plus 3 times 2n plus 1 . And we're looking at the absolute value of this as n approaches infinity, the limit. So things cross off now. X to 2n plus 1, 3 to the 2n plus 1. And as n goes to infinity, those cancel each other off. So what we're left with is 3 squared, or 9 times x squared. This needs to be less than 1. So x needs to be less than 1/3. So that's my interval of convergence. In the next question, we are looking at the next question part B says evaluate this following series. And on first look, you would be thinking, oh, look, I don't even know what to do, where to start. However, what we recognize is this is just, it's of this form. The only difference is that instead of having, our x, we've replaced x with 4. So this is the series expression for arc tan of not x, but 4. So when it says find this or evaluate this, that is what that is the answer. That's the solution or the evaluation of that series. Okay, C and D are really just kind of side parts of this question that force us to remember convergence for P series, whether it's alternating or not. So in the first one, we notice that because it's alternating, if it's alternating, we just need to check whether or not the n plus 1 term is less than the nth term, and that's true, and that the limit as n approaches infinity of a sub n equals 0, and that's also true. So therefore, in order for this to converge, these conditions are met provided that p is greater than 0. So as long as p is greater than 0, what we have is, for example, 1 over n squared or n cubed or n to the 1.1. As long as these are positive exponents, 1 over n to the p will decrease and meet these conditions. And then this is part C. So the answer, p must be greater than 0. And in the next one, it's not alternating, so it's a p series test, 1 over n to the 2p. We know that 2p must be greater than 1 from the p series test. So therefore, p must be greater than 1/2. So that's the first